Hello everyone, welcome to yet another video of electromagnetic fields. So in this video series we are going to discuss about important unit in electromagnetic fields, which is electrostatics. So when we talk about electrostatics, the first law that gives the force between two charges is the Coulomb's law. So in this particular video we are going to discuss about the law that governs the electrostatic fields, which is the Coulomb's law, and then we are going to discuss about electric field intensity. So now let's see what the Coulomb law states. So when we take two charges, let it be Q1 and Q2, when a charge Q2 is moved towards another charge Q1, it experiences a force. It experiences either a force of attraction or repulsions. So that force can be calculated using the Coulomb's law. So the Coulomb's law states that the magnitude of the electrostatic force of interaction between two charges is directly proportional to the product of the magnitude of charges and is inversely proportional to the square of the distance between them. So the force acting on the two charges is the either repulsive or attractive. If the force between them is repulsive, then the sign will be minus. If the force between them is attractive, then it will be indicated through plus sign. So in mathematical way, we can tell F is directly proportional to Q1 Q2 by R square. So here the distance between the two charges Q1 Q2 is represented as R21. So therefore the magnitude value of the force, so modulus of F is equal to Q1 Q2 by R square. If we remove the proportionality constant, we have to introduce if you remove the proportionality, we can introduce a constant which is nothing but K, where K is 1 by 4 pi epsilon. So F is equal to K Q1 Q2 R square, where F is the electrostatic force and Q is the charges and R represents the distance between them. Now let's see what is electric field. The electric field describes the electric force experienced by a motionless positively electrically charged test particle at any point in space. So a charge is surrounded by an electric field. Whether it is at rest or whether it is at motion, there is a field around it. When it is at rest condition, the field around it can be termed as electrostatic field. So it is nothing but electric force experienced by a motionless particle, and this force is responsible for the attraction and repulsion of the charges when it comes to another charge. So this concept of electric field was first introduced by Michael Faraday. Now let's see the basic fundamental of electric field is the electric lines of force. Now let's see what is an electric lines of force and what are its properties. They always originate on a positive charge and terminate at a negative. So now let's see about the properties of electric lines of force. These electric lines of force always originate on positive charge and terminate on negative charge. So always it starts from plus and ends at the minus. They always leave or enter a conducting surface at right angles to each other, and also they never cross each other. That is a unique feature of electric lines of force. Just like a magnetic field, each lines of force will not interact with each other. So these lines will not cross each other. And also the lines of force have same direction of repel and have opposite direction when it attracts. So these are the main properties of electric lines of force. Now let's see what is electric flux density. So the basic fundamental element for an electric field is the lines of force, and when it is calculated for a unit area, it is termed as electric flux density. So electric flux lines on a unit area is called as flux density. So flux density, electric flux density, it is defined as the flux per unit cross-sectional area emanating normally from surface. So it is represented by the letter D, and D is equal to Q by A, because we know that Q is directly proportional to, Q represents the charge, where the charge can be proportional to the flux lines. So therefore Q is equal to Q by A. So here D is the flux density in Weber per meter square, and Q is the total flux in Webers, and A is equal to surface area. D can also be represented as Tesla. And here, if we observe this equation, D is equal to Q by A, which means that this D is independent of the permittivity. So therefore, whatever may be the permittivity of the substance, the flux density is independent of it. Now, let's see what is meant by electric field intensity. So, electric field intensity E is the force per unit positive charge. The force experienced by a unit positive charge is called as electric field intensity, or we can tell it as the electric field strength. The force, the strength experienced by a positive charge, a unit positive charge, is called as electric field intensity. So, this can be written mathematically as E is equal to F by Q, and we also know that F is equal to Q1 Q2 by R square from Coulomb's law. So therefore E is equal to Q1 Q2 by Q into R square. Here this Q represents either Q1 or Q2 based on towards which the charges moves. So therefore we can reduce the equation into E is equal to Q by R square, because F is equal to Q1 Q2 by R square, and we already have Q in this EMF electric field intensity equation. So therefore E is equal to Q by R square, and if you want to represent it as a vector, E vector is equal to F by R square into AR vector. So here this electric field intensity is equal to the electric potential gradient in magnitude, and also it is equal to the lines of force passing through a unit cross-sectional area at that point. Now let's see what is electric potential. So the electric potential at a point is equal to the electric field energy of any charged particle at that location divided by the charges of the particle. So electric potential is the amount of external force you apply on a charged particle to move it from one position to another. So the energy you impart on that charged particle, or the force you externally apply on that charges, is called as electric potential. So when you apply that force to the charged particle, you are making it to move against the electrostatic field that is already surrounded against it. So we can mathematically represent it as V is equal to minus integral EdL, because electric field intensity, it flows in one direction, but electric potential is something that we apply externally, so it always travels opposite to the electric field. So therefore VE is equal to minus integral EdL. So this negative sign represents that this potential is always against the electric field. So electrical potential is the amount of work done by a unit positive charge that moves from one point to another. So it is a property that related to electric field itself, and it is not a test particle. So through this video we have discussed about what is meant by Coulomb's law and what is electric field. So the basics of electric field arises from lines of force, and then electric flux density, and then we moved on to electric field intensity, and finally we looked at electric potential. So I hope in this video we had discussed clearly about the law governing the force between two charges and what is the electric field, what it actually is. So in the next video we will discuss about the other laws which are concerned to electrostatic fields. So thanks for listening.